Welcome Intro to College Algebra students. Today we're going to be looking at the forms of linear equations and especially slope, because there seems to be a big emphasis on that on the TSI and also on the SAT to an extent. So most of you are pretty good with the fact that slope is rise over run. So the change in y over the change in x. So I'm not really going to belabor that point much either, because you guys are pretty good with that. You guys are also pretty comfortable with the fact that if you have a line in y equals mx plus b, which is slope-intercept form, you're pretty good at knowing what's the slope and what's the y-intercept. So this is the slope, and this is the y-intercept. So again, I'm not really going to belabor that. Go ahead and write that if you feel like you need to, or if you just want complete notes, I guess. And we're going to move on. So here's what students tend to have trouble with. Let's say I have some other line in some other form. Maybe it's in standard form. Maybe it's just in some random form that isn't anything special, like, I don't know, 3 minus 4x plus 7 plus y. Now let's make it like 2y. Why not? Equals 1. I'm probably going to regret that choice. I'm going to be honest with you. I'm going to regret writing this equation. But that's okay. We'll regret it together. It's togetherness. It's important. Anyway, I want the slope of this line. Now, if you have a graphing calculator at your disposal, I think the easiest way to do that is probably to graph this sucker and figure out the slope this way. However, if you're taking the TSI, you are not going to have a graphing calculator at your disposal. So you're going to have to figure out some other way to do it. And I'm going to suggest that in many cases, you can turn this mess into this. So let's try that. So what are the features of this? Basically, what's special about slope-intercept is that I've got the y all by itself. I've got only one x. It's got a number in front of it, and then my other constants are all here. So when you look at a mess like this, what I want you to think about is basically simplifying the equation, just like we did a couple weeks ago in class. You want the y all by itself, and then you kind of want everything else to be simplified and combined as much as possible. So I'm going to start, in this case, I see that the y is almost by itself. It's got a 2 there in front of it, which we'll get rid of later. But for the most part, it's like we've almost got it by itself. So I'm going to go ahead and just leave him alone for right now. Just leave it there. And we're going to move it by itself here in a minute. Then I see I've got this other craziness going on. Like there's a 3 minus, and then there's something here I need to distribute, and then there's a 1 over here all by itself, which is not supposed to be by itself. It's supposed to be with everything else. So I'm going to start by distributing. That's always a good first step if you have the opportunity. Go ahead and distribute. So let's do that. 3 minus, now 4 times x is 4x. Then negative 4 times 7 is negative 28. And then plus 2y equals 1. Okay, now again, look at this. Look at this. Notice that my y is almost by itself. I need to get it, I need to get everything else away from it, and then I'll need to divide it by 2. But that's going to be fine. And then I've got my x here with a number in front of it, which is cool. That's what I want. And then I have all these other numbers hanging out. So these guys, I want to combine them together. And then after I do that, I'm going to want to combine it with this 1 over here. So now here's what sometimes people want to do. They see two numbers on the same side of the equation and they want to do like plus 28 plus 28. Don't do that. These are on the same side of the equation. All you need to do is combine them together using addition or subtraction. You're just combining like terms. You are not doing reverse PEMDAS. You are not doing inverse operations or anything like that. So just combine these together. What is 3 minus 28? Well, 3 minus 28 is negative 25. Think you've got $3 in your pocket, you owe somebody $28. After you pay them, you still owe them another 25. So minus 25. And then just go ahead and write down the rest of it. I have minus 4x plus 2y equals 1. Okay, it's looking better actually. Now again, look at your goal. Notice I should have the constants. We call these constants when they don't have a variable with them. Should be kind of all together at the end. So what I'm going to do is combine the negative 25 and the 1. But since there's an equal sign here in the middle, this is where I have to do the opposite. And I'm going to add 25 and cancel that out. So I have, on this side, I have negative 4x plus 2y equals now 26. Okay, it's looking better already. So I should have the y by itself here, and then I really need the x on the other side of the equation. So I'm going to move this whole thing. Don't try to just add or subtract x. Don't try to divide x. You're just going to move this entire thing by canceling it out, which you do by adding 4x, adding 4x. So 2y equals, here's another mistake I see a lot. Somebody sees that and they go 30x. Take a second and think, why is this not 30x? Why is that the wrong thing to write? And hopefully you said, because these are not like terms. I can't take 26, just 26, and add it to 4 x's, because I don't know what x is. X could be 100 or a million. And in that case, I'm adding $26 to $4 million. That is not $30 million. That's not how that works. So I just need to keep these separate. I just have 4x and then plus 26. And then I'm actually shocked, guys, that this is going to work out nicely, because I just made these numbers up. I figured it was going to look real ugly, and it doesn't. That's awesome. Go me. Go me. We're almost done. Look at this. What's the only thing wrong with it now? I should have a y by itself. I got a 2y. Thought I'll get rid of the 2. Think, what is the y doing to the 2? If they're right next to each other like that, they're really multiplying. So to undo multiplication, you just divide. And then I'm going to have y equals 4 divided by 2 is just 2, so 2x. And then 26 divided by 2 is 13. So after all that work, what is the slope of this line? The slope is 2. Check that out. Let's try another one. So I got 2 ways to do this. I can do this process again, put it in slope-intercept form. Or I can actually just find 2 points. How about I actually write the question? What is the slope? Or I can find 2 points and use a rise over run to figure out the slope between them. I'm actually going to show you both methods. So I'm going to show you both methods. Method number 1, convert to y equals mx plus c. So slope intercept, y equals mx plus b is shorter to write, so I'm going to write that instead. I can convert it to that form, or method number 2, I can find my 2 points, and the easiest 2 points to find are usually your intercepts if it's its standard form. Okay, so this method, again, is the same thing we were just doing here. It's just going to be a little easier because this is not such a messy equation. So I'm going to start by, here's my dude. Here's my equation. Isn't it beautiful? And remember, I want the y by itself, and I want the x, so look at your form, oh, here it is. You want the y by itself here, and you want your constant at the end, and you want your x term with the constant on the same side of the equation. So I have nothing to distribute like I did on this one. And I also have no like terms to combine. So all I really need to do is kind of where I was here. This, in fact, this looks like the same form as that one. I'm going to cancel out the x term to bring it to the other side. And then I'm just going to divide by whatever's in front of the y. So I cancel 3x by subtracting it. And negative 3x plus 30. And then remember, these are not like terms, so it is not 27x. Don't do that. So you cannot combine them because you don't know what x is. And then I just need to divide by a negative 5. And that means y equals, now negative 3 over negative 5. Those negatives cancel each other out. So this is just 3/5 x. And then ignore that guy. 30 divided by negative 5 is negative 6. So the slope is 3/5. So up 3 over 5 is the slope. And so that's the same method that we just did up here. So not too bad. Then the other way to do it is to find 2 points, or really any 2 points. But I'm going to show you that when it's written like this, the intercepts are the easiest ones to find. And then we're going to do rise over run. So I have my equation, 3x minus 5y equals 30. What I want to do is figure out the 2 points. If x is 0, what is y? And if y is 0, what is x? So, if x is 0, right here, if x is 0, then this whole term with x in it goes away. You can even just cover it up. And then negative 5 times what gives me 30? Well, negative 5 times negative 6 gives me 30. So my y-intercept, and we already knew that from over here, but pretend we hadn't done that, okay? So my y-intercept is 0, negative 6. Then I'm going to do kind of the same thing here for the x-intercept. If y is 0, then I have 3x minus 5 times 0 equals 30. So that goes away. 5 times 0 is 0. That just vanishes. And then 3 times what is 30? Well, 3 times 10 is 30. That means this is 10. And then I'm going to do, I have 2 points. So again, any 2 points with the intercepts are the easiest ones to find, often. I'm going to do rise over run. So rise over run. Okay, so when you're doing rise over run with points and you don't want to use the formula, you just have to stay consistent where you start. So if I'm going to start here and go here, how far did it go up? From negative 6 to 0, it went up 6. And from 0 to 10, so this one went up. From 0 to 10, that's also going to the right, so that's a positive. 0 to 10, that goes up 10. And then notice, if my slope is 6/10, I just need to simplify it to get what I had before. I can divide those both by 2, and I get 3/5. So I still get that my slope is 3/5 either way. It really just depends what method you prefer.